In this lesson, we will talk about the possible risks and challenges in machine learning and data science. The first risk is overfitting. This means that our learning process leads to the definition of models that are excessively based on the available data. The result of this is that we obtain a model that is too specific and that depends on the known data and therefore does not generalize well on new or future data. This typically happens because too few data are available, the model is too complex, or too many learning steps are performed. It is therefore possible to obtain a behavior as shown here. We see that the error over the training data is continuously decreasing, as the model adapts better, while on the contrary, the error on any test data from a certain point on starts to rise again. This is because the model is overfitting on the training data, and it is not able to analyze new data correctly. The second risk is the one of the so-called bias. Essentially, since the machine learns only from the available data, it will be heavily influenced by this data. If the data is biased, also the learned model will be biased. In certain application scenarios, this can be very problematic. For example, if you want to use machine learning techniques to categorize people, and you have datasets that leave out or penalize minorities or disadvantaged categories, our algorithm will learn such bias. Another kind of bias is the so-called cognitive bias, that is, the observer's bias, or the fact that any observer modifies and interprets a reality in a subjective way by introducing alterations of it based on his own sensitivity. Behavioral science categorizes dozens of different possible biases of people. The important thing is to keep this in mind, as in our role of analysts and implementers of data analysis, we will inevitably be subject of this problem. Content or source bias is also a very important point. When we carry out an analysis, we must always keep in mind the question we want to answer. We will need to verify if the collected data can respond to the question we are asking. In general, content bias can come from aspects related to the source, the technology or platform used for data collection, the consumer or user demographics, or their different behavior. For example, when collecting information about the volume of check-ins in the different places of a city, we must ask ourselves, what is the question we are addressing? Are we describing the dynamics of the city, or the location of its inhabitants? Or are we simply describing a very specific population, that is, users which use a specific digital platform using some specific devices according to a well-defined pattern of behavior? In many cases, using different data or different sources can bring completely different interpretation of reality. For example, this heat map shows the density of geolocated photos published on Flickr in the city of Milan. The analysis, that collects more than 300,000 images, shows strong density in the most important or beautiful areas of the city. Conversely, if we use a platform like Instagram as a source, what we get is a completely different interpretation of the same city. The density is now evenly distributed over the entire area. Indeed, this is how people use Instagram in their everyday life. The third problem relates to the quality of the data in terms of accuracy and completeness. This is a widespread problem to the point that, for example, Gartner estimates that 1/3 of the world's largest companies may have problems with the quality of their own data. The critical aspect is that when we perform data analysis, some kind of results will still be obtained even from incorrect or bad data. The problem is that the corresponding results will also be incorrect. This will create a vicious cycle, which starts from bad data, produces wrong results, and ultimately will lead to incorrect decisions and therefore wrong business strategies. To overcome this problem, we need to pay a lot of attention in improving the quality of the incoming data, using so-called data wrangling techniques. That is, all the processes that transform the raw input data into good quality and complete data, ready to be supplied in input to the next steps of the data analysis pipeline. The steps to be implemented in the data wrangling process include understanding, exploration, transformation, augmentation, and shaping or formatting of data. This process requires many iterations and is actually rather tedious. Unfortunately, despite the prominent role assigned to data science today, it has been even selected by the Harvard Business Review as the sexiest job of the 21st century. Often, a large portion of the data scientist's time goes into data cleaning operations. As an example, I'd like to mention a data collection project implemented in Milan, Italy, to study interesting venues. When collecting such data from platforms like Foursquare, it turns out that over 50% of the recorded locations are dirty, irrelevant, obsolete, or fake. If we implemented any kind of analysis on the data without a preliminary cleaning process, we would have obtained totally biased and irrelevant results. Another problem is that data can be organized according to different granularity in time and space. When you want to integrate different data sources, it is necessary to make granularity uniform across sources, through mechanisms like scaling, aggregation, or grid definitions over the data. For example, on a geographical scale, it may be necessary to construct grids, either with regular structure, fixed cell size, or with irregular shape based on business needs. In the example picture, you can see data that combine presence of people and position of events. In this case, the two datasets are made uniform through a fixed size grid on the map. In this second example, you can see a customized grid over a city, where the cells represent geographical areas based on the coverage of cellular telephone antennas. This leads to problems related to comparability of data and its general consistency. Unfortunately, the complexity of granting consistency across sources is often very high, even in apparently simple situations. For instance, let's pick the problem of understanding if two described places are actually the same location or two distinct ones. This can actually become very challenging. Unfortunately, both in terms of textual description and geographical position described by GPS coordinates, we would hardly have a perfect match. It is therefore a question of finding strategies for partial similarity, based on empirical rules, that can find optimal solution for making the decision. For example, one can consider a limited number of decimal places in the GPS coordinates, or a partial similarity of the descriptive text. The last problem we face goes well beyond the technical aspects. It can in fact be considered a problem also at the market and social level. It concerns the accessibility and availability of data. Indeed, we can talk today about the so-called data divide. That is, the phenomenon for which the ability to access data becomes strategic for competitiveness. Basically, entities that can have access to data or that are able to collect enough data to understand the reality in a better way have a competitive advantage over those who fail to do so. Think about large online retailers like Zalando or even Amazon or eBay. They have a huge amount of information for understanding their customers. This is not the case for small businesses. Even companies that decide to make their data available to the public usually share a certain amount of data, while they keep for themselves the part that is most relevant and valuable for the business. For example, even the data in Google Maps describing the venues is only partially available for automated use. While the basic elements describing a venue are all accessible to third party through API access, the most valuable part, that is the number and dynamics of presence of people in the venues, is not accessible via API. To conclude, I would say that the message we collect from this journey through the risks and challenges related to data science is that if we want to extract the highest value out of the gold mine represented by data in the modern world, we must bear in mind that this will involve a considerable preparation effort in terms of data cleaning and selection. We will also need to explore the best ways to analyze the data, remembering that you will have to face various problems and probably try many different ways before finding the best solution.